Well, hello again, everybody, and welcome to another Sun Devil Learning Labs lesson on fractions. My name is Michael Barker. I'm going to be your instructor today, and we're going to continue with some of our lesson program that we've been going on this summer. Today, our objective is to multiply non-unit fractions by non-unit fractions. So our numerators could be the same, but our denominators will definitely be different. Before we start, let me remind you of a few things that I always try to remind everybody before our lessons. And number one, let's make sure you're in a comfortable setting with no distractions. No little brothers or sisters running around and into the room, no dogs or cats or somebody jumping in your laps, no television on in the background, no music playing. And if you have trouble getting into that setting, talk to your parents or whoever's in charge and see if they can't help you get into a better learning environment. And secondly, gather any supplies you might need today. I'm going to suggest a couple of pencils, a notebook. I hope you're keeping a notebook for these lessons. If not, at least several sheets of paper. Scissors are sometimes helpful, but a ruler is almost always going to be useful for drawing area models, number lines, just about anything you want to do. You can be a little more accurate with the ruler when you're drawing. And finally, be sure and use the restroom before we start. Remember, you can always pause the video if you need to take a break, or if something goes too fast, or if you want to just review and repeat a lesson or part of a lesson so that you can better grasp what's going on, just go ahead and pause the video and go back. You're on your own time, I guess is what I'm saying. So let's get started. We're going to start today with a little bit of review. We're, again, multiplying non-unit fractions by non-unit fractions. So in our review, we want to write 1/2 of 1/3 as a multiplication expression, and then we're going to solve that. So let's look. Our review of writing that problem would be, let's first draw an area model and divide it into thirds, 1, 2, 3. But we want 1/2 of one of these thirds. So that would be, this is 1/2 of 1/3. We can count the parts. We have 1, 2, 3, 4, 5, 6. So we have one of 6 parts. And we can look at that mathematically as well, because we have 1/2 times 1/3. We know our rule. I've made a note here. If we see this note, that means it's something we should probably keep track of and write down. We know if we multiply the numerators, then multiply the denominators, we'll get our result. So 1/2 times 1/3 is 1 times 1, gives us a total of 1. And our denominator, 2 times 3, gives us 6. So our 1/6 is the same solution that we got when we drew the area model. Another thing that we need to review is writing some fractions as decimals. This is just to refresh you from a previous lesson. So why don't you just take a couple of minutes and work on that, and we'll get back and go over my solutions in a minute. Okay, hopefully your worksheet looks something like that. 1/10 is going to be 0.1, 3/10, 0.3, and 7/10, 0.7. And if we moved down to hundredths, we would have 1/100th is equal to 0.01, 8 100ths, 0.08, and 17 100ths would be 0.17. And finally, let's start with a sample problem. If this application problem is, I'll read, Kendra spent 1/3 of her allowance on a book and 2/5 on a snack. If she had $4 remaining after purchasing a book and a snack, what was the total amount of her purchase? This should be a fairly straightforward problem for students that have completed the first parts of the course, because we've worked on problems. This is really more of a bit of addition and subtraction. I think we'll use a tape model. I've emphasized she spent 1/3 of her allowance on a book. We have the book in 1/3 and 2/5 on a snack. 1/5 and 1/5 would be 2/5, and that's all on the snack. And now we have an amount left that we don't know what it was, but we know she spent 1/3. We know our common denominator is going to be 15. I guess we should do first. 3 times 5 is 15, and 5 times 3 is 15. So when we convert to like fractions, 1/3 becomes 5/15. 2/5 becomes 6/15. Therefore, if we know she spent 5/15 of her money on the book and 6/15 of her money on the snack, what was she spent a total of 11/15. Means she had 4/15 remaining of her money. And what we can do now is look at those 4/15, and that remaining part we can break into 4 parts. It would be, I'll move up here so we can see what's going on. I'll move over here today. We have 1, 2, 3, 4 15ths. Okay, we figured that out. And now we know our 4 units is the same as $4. We know 1 unit is the same as $1. So 15 units is going to be $15. So if the book was 5 units, her spent $5, and the snack was going to be $6, 6/15, that was $6. And we know that the book then had to be $4 because of 4/15. I mean, that's how much money she had left over. So she had 6, 5, and 4 gives us a total of 15. And Kendra's allowance is $15. So now let's work on a problem that we can work on by ourselves. And we'll try to do this one. Go ahead and try this. And it's going to be multiplying 2/3 of 3/4. Take a look at that, and then I'll come back and we'll go over it with you in just a minute. This one should be pretty straightforward. Okay, 2/3 of 3/4. We would write it numerically, 2/3 times 3/4. So let's start with an area model. We may as well draw, we want to know how much 2/3 is of 3/4. So we need 1, 2, 3, and there's our 4th part, 3/4. That's what we're going to start of. We want to know how much 2/3 of 3/4 is. So our next step should be, why don't we break our same unit, but now we want to break it into thirds, and we use horizontal lines. And we break it into 3 equal sections horizontally. We have 1, 2, and 3. So 2/3 of 3/4. And now what we have to do is look at how many of the units are shaded. And in this case, we have 1, 2, 3, 4, 5, 6. And we know that's 2/3 is the same as 6/12. Because 2 times 3 will be 6, multiplying the numerators. Then we want to multiply our denominators. There's our friend in the notebook. We should know these little rules by now. That gave us 12. 6/12 is going to be the same as 1/2. We simplify is all we're doing there. So now you try writing one 2/3 of 2/3. Take a few minutes and work on this one on your own, and let's see what you get, and then we'll go over my solution when I come back. Okay, here we go. Hopefully you set up something like this. You should have seen that your area model first needed to be 2/3 out of the whole unit, 1, 2, and there's our 3rd unit. We broke it into 3 even parts. And then we also wanted to know then we needed to break it into 2/3 going in the other direction, the horizontal direction. So again, we broke it into 1, 2, 3 strips, and that's also 2/3 when we shaded just the blue. So now all we have to really do is count our areas, and we see we have 4 out of 5, 6, 7, 8, 9 areas. And our numeric expression will show the same thing. 2 times 2 is equal to 4. 3 times 3 is equal to 9. 4/9. And that's what 2/3 of 2/3. And we really can't simplify that anymore. So our solution would be 4/9. Okay, now let's work with some slightly larger numbers, and let's see if you can use the rules of multiplication that we've been talking about to solve these problems. And if you just multiplied the numerator and the denominator, 7/9 of 3/7 would give us 7/9 times 3/7. 3 times 7, 21, and 9 times 7 is 63. You could also multiply the numerator in the second part, and you have 3 times 5, 15, and 10 times 9 for 90. And we'll do the last one, 5/8 of 4/15. 5 times 4 is 20, and 8 times 15 is 120. I think you can see that all these fractions need to be simplified, and then when we simplify, 21/63 becomes 1/3, 15/90 1/6, and 21/20 becomes 1/6. Now, myself, I think these numbers are starting to get a little big, and we may even need a calculator or a multiplication table just to do some of these problems. And it gets to be maybe a little bit time-consuming and impractical. So what would you think if we were to simplify first? If we take and we simplify these problems and work on trying to make things a little easier before we make our final solution. For example, when we started there, we could have taken 7/9. We know that 7 and 7 understand, we can simplify them to 1. 7 goes into 7 one time for each of those. And then in our second step, we know 3 can go into 9 3 times. So 3, it becomes 1, 9 becomes 3. We're just simplifying. And now what do we have? We have 1 times 1. It's going to give us a total of 1 for the numerator. And our denominator now is 3 times 1. And so 3 times 1 is 3. 1 times 1, 7/9 of 3/7 has simply become 1/3, and we didn't have to do all that, the multiplication with the larger numbers. Take a look and see if you can simplify the other two in our first problems. And when we come back, we'll go over and see how you did. Okay, now let's take a look at what you did. I did my worksheet in a similar way as the first one. Let's see, for 3/10. 3 can go into 9 3 times, so 3 becomes 1, 9 becomes 3. And 5 can go into 10 twice, so 5 becomes 1, 10 becomes 2. Now we have 1 times 1 will give us 1. And 2 times 3 gives us 6. 1/6, the same answer we got, with a lot smaller numbers and easier to work with. One last one. We had 5/8 of 4/15. So when we reduce 5/8, 5 can go into 15 one time and 3 times. And then our 4 and 8, 4 is 1, 8 becomes 2, 4 goes into 8 twice. So now we have 1 times 1 is 1, and 2 times 3 is 6. I think you can see that these are all a lot simpler numbers to work with if we just simplify our fractions first, when we can. We can't always do it, but when we can, it makes our life a little easier. Okay, let's look at another practice problem. And this is it's a word problem, but it's not really that complicated. And I'm going to walk you through it. So Nigel completed 3/7 of his homework immediately after school, and 1/4 of his remaining homework before supper. He finished the rest after dessert. So what fraction of his work did he finish after dessert? Actually, I think what you should do is take a few minutes and see what type of solution you can come up with, and then I'll share with you how I did mine. This is similar to what we were doing before, and there's just a couple of different ways. There's no wrong way, really, as long as you just find a way that's more comfortable for you to work. All right, we're back, and it's the same problem we were looking at when we left. Hopefully you were able to come up with something. I'll tell you, I decided to look at the problem with the tape diagram to help myself here. And I know that he did 3/7 of his homework. So I first broke the total amount of homework into sevenths. 1, 2, 3, 4, 5, 6, 7. So after school, he did 1, 2, 3/7 of his homework. And then he did another seventh. Well, what they said he did was 1/4 of the part that was left. Well, it happened to be that there was 4/7 left, right? So he did one more seventh. So now we could just count our tape diagram and you could see that we'd have 1, 2, 3/7 left that he did after dinner. But if we were to not draw the tape diagram, we would also know that if he did 3/7 before dinner or before he did the other work, we know that what we're working with is what's left is 4/7. And if we know he did 1/4 of the remaining homework, that means that there was 3/4, right? If he did 1/4, that means he had 3/4 left of the remaining. And the remaining was 4/7. So our question would be, what is 3/4 of 4/7? And 3/4 of 4/7, we can just multiply numerator. 3 times 4 is 12. Denominator, 4 times 7 is 28. Simplify 3/7. What a coincidence. It's exactly what we did on the tape diagram. So we know that Nigel finished 3/7 of his homework after dinner or after dessert. So now I'd like to see if you can solve these multiplication with a multiplication sentence and draw an area model to explain your thinking. Take 5 to 10 minutes, and when you're done, I'll come back and we'll go over all 6 of the solutions. Okay, welcome back. Let's take a look at how we would have solved the first 3. We'll start with our first one. 2/3 of 3/5. By now we should know that that changes the multiplication. 2/3 times 3/5. Multiply numerator, 2 times 3 is 6. Denominator, 3 times 5 is 15. 6/15 can simplify to 2/5. We can draw an area model. If we want to start 3/5, we'll break our box into parts of 5. 1, 2, 3, 4, 5. And we want 3/5, so that'd be 1, 2, 3. Then we want 2/3 of all of that. So now we take our box and our area model and we break it into thirds horizontally. 1, 2, 3. And out of 2/3, how many of those overlapped with our 3/5? And we can count again. 1, 2, 3, 4, 5, 6. 6 out of 15 total boxes. So 6/15 simplifies to 2/15. But again, a lot more work if you can get comfortable just doing the numerical method and a little bit of multiplication. 3/4 of 4/5 becomes 3/4 times 4/5. Multiply 3 times 4, 12. Our denominator 4 times 5 is 20. Simplify 3/5. Again, we can look at an area model. 4/5, we broke our box into 5 sections vertically. We also have to break it into 4 sections horizontally. And where the shaded area shows how many of the units overlapped. And what did we come up with? 12 out of 20 total units. Again, 12/20 simplifies to 3/5. Finally, your last one should look something like this. 2/5 of 2/3. 2/5 times 2/3 should give you a total of 4/15. For 4/15 on the area model, where first we want to know 2/3, break our box horizontally or vertically into thirds. And then we're going to go horizontal into fifths. 1, 2, 3, 4, 5. How many of our units are in the same shaded area? 1, 2, 3, 4. Out of how many total units? 4/15. A fraction is already simplified as it'll go. So that should be the first three problems. Let's take a look at the next three. We had 4/5 times 2/3. It doesn't say of, but we know we already have to multiply. 2 times 4 will give us 8. 3 times 5 is 15. Your area model should look something like this. We break it up into thirds, 1, 2, 3. Then we break it up into fifths horizontally. And we count the shaded areas, 1, 2, 3, 4, 5, 6, 7, 8. Out of the total amount of 15, we get 8/15. Let's look at our next problem. 3/4 times 2/3 is the same as 6/12. 2 times 3 is 6. 3 times 4 is 12. 6/12 will simplify to 1/2. That should be simple enough to see. Or our area model, if you still need it. 2/3, we broke it into thirds in one direction and fourths in the other. And what that gave us in the shaded areas was 1, 2, 3, 4, 5, 6. 6 out of 12 simplifies into 1/2. Hopefully you can see that half of the whole model is shaded. And finally, 3/4 times 5/6. 3 times 5 is 15. 4 times 6, the denominator, 24. 15/24, we can divide both of those by 3. Simplify to 5/8. And again, I've got an area model here. We draw 6 bases, and then we draw 4 horizontally, 1, 2, 3, 4. Shaded areas totaled 15. Overall units was 24. 15/24 is equal to 5/8. Hopefully your work looks something like this, or if not, you can use this to correct any mistakes you might have made, or go back and see just exactly how you might change how you solve things. Now we're going to try solving by simplifying first. I want you to draw an area model if you need to. When I give you the answers, I'll provide one. But for now, see if you can simplify 3/4 times 5/6, 4/5 times 5/8, or 2/3 or 6/7, and see how you can do simplifying. And then we'll solve doing that method and see where that brings you to. Take about 5 minutes. It shouldn't take you, well, it may if you draw some things, 5, 6 minutes to do these three problems. And we're back, and I'll show you what my board looked like. Let's see what we have here. 3/4 times 5/6. So 3/4, our 3 can go into 6 twice. So 3 becomes 1, and 6 becomes 2. So now we're multiplying 1 times 5 and 4 times 2. So we get 5/8. We can draw an area model. Break our unit into 6 units. 1, 2, 3, 4, 5, 6. And then we're going to cut it up into fourths going horizontal. 1, 2, 3, 4 rows. How many are shaded? We have 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And how many do we have overall? 24. 15 of 24, again, simplifies to 5/8. Hopefully your work looks something like that. Let's look at another one. 4/5 times 5/8. Let's see what we have here. Well, 4 can go into 8 twice. So we have 1 4 and 2 8s, and then 5 and 5 are the same, so they both can simplify to 1. So what do we wind up with? We wind up with 1 times 1 is equal to 1, and 1 times 2 is 2, and that is equivalent to 1/2. So how would we mark that in our area model? Very simple. We'll first break it into 8 even parts, 3, 4, 5, 6, 7, 8. And then we're going to break it into 5 horizontal parts, 1, 2, 3, 4, 5, of which 4 are shaded. So how many shaded parts did we have? Well, we had 20. And then how many total parts did we have? Well, we had 40. So 20 of 40 is the same as 1/2. I hope you can see here now that these area models can start to get a little troublesome to draw, and even they're more complicated than trying to maybe multiply and use a calculator. That's why we can't emphasize enough how important it is to simplify your fractions when you can. So now we're going to we'll do 2/3 times 6/7. Well, 2 and 7, they have no common multiples, so they're going to have to stay the same. But 3 and 6, they can be multiples. 3 and 6 becomes 1, and 6 is 2 3s, so that's 2. So now our solution would be 2 times 2 is 4, and 1 times 7 is 7. So 4/7. Again, we can't simplify. So let's see, we can do our area model. 1, 2, 3, 4, 5, 6, 7 rows this way, and then 3 rows horizontally, 1, 2, 3. You can see we have 12 out of the 21 units shaded, which will simplify to our 4/7 solution. Again, I hope this makes sense to you, and I hope it gives you a chance to look towards some more practice. Finally, I'd just like to say thank you and remind you in our learning guide, there are some other resources and there are some other lessons that you can go to if you want to continue practicing and continue working on multiplying non-unit fractions by non-unit fractions. Until I see you for the next lesson, I hope you have a good day, and I hope you're getting pretty handy at this.